Skyscrapers are impressive feats of engineering that allow us to live and work in densely populated urban areas. But these towering structures also have a hidden impact on the ground beneath them. In this section, we will explore how the weight of skyscrapers and other buildings affects the ground and causes subsidence. Subsidence is the gradual sinking or settling of the ground surface due to various factors, such as natural compaction of soil, extraction of groundwater or oil, mining activities, or human-induced loading. Skyscrapers are one of the sources of human-induced loading, as they exert enormous pressure on the foundations that support them. Depending on the type and quality of the soil, the foundations may sink into the ground over time, causing the building to tilt or crack. The amount of subsidence caused by skyscrapers depends on several factors, such as the height and mass of the building, the size and depth of the foundations, the distribution and arrangement of the load-bearing columns, and the geology and hydrology of the site. For example, skyscrapers built on soft clay or peat are more prone to subsidence than those built on hard rock or gravel. Similarly, skyscrapers with deep pile foundations that reach bedrock are more stable than those with shallow spread foundations that rest on loose soil. One way to measure the subsidence caused by skyscrapers is to use satellite-based radar interferometry, which can detect millimeter-scale changes in ground elevation over time. This technique has been used to monitor the subsidence of several cities around the world, such as Bangkok, Jakarta, Shanghai, and Mexico City. Some of these cities have experienced significant subsidence due to a combination of factors, including skyscraper construction, groundwater depletion, and land reclamation. For example, Bangkok has been sinking at an average rate of about 1 centimeter per year since 1978, with some areas sinking as much as 10 centimeters per year. This is mainly due to excessive pumping of groundwater for domestic and industrial use, which lowers the water table and causes the clay layers below to compress. Skyscrapers also contribute to the problem by adding more weight to the already stressed soil. According to a study by Chulalongkorn University, some skyscrapers in Bangkok have sunk up to 20 centimeters in 10 years. Another example is Jakarta, which has been sinking at an average rate of about 3 to 10 centimeters per year since 1982, with some areas sinking as much as 25 centimeters per year. This is also mainly due to excessive groundwater extraction, which has caused land subsidence and seawater intrusion. Skyscrapers also play a role by increasing the demand for water and putting more pressure on the ground. According to a study by Bandung Institute of Technology, some skyscrapers in Jakarta have sunk up to 40 centimeters in 10 years. Subsidence caused by skyscrapers can have serious consequences for urban infrastructure and environment. It can damage buildings, roads, bridges, pipelines, and drainage systems. It can also increase the risk of flooding, especially in coastal areas where sea level rise is already a threat. Moreover, it can affect the natural ecosystems and biodiversity of the area by altering the hydrological cycle and soil properties. To prevent or mitigate subsidence caused by skyscrapers, several measures can be taken by engineers, planners, and policymakers. These include conducting thorough geotechnical investigations before designing and constructing skyscrapers to assess the soil conditions and suitability of the site, choosing appropriate foundation types and depths for skyscrapers based on the load-bearing capacity and settlement characteristics of the soil, distributing and arranging the load-bearing columns of skyscrapers in a way that minimizes differential settlement and stress concentration, monitoring and maintaining the foundations of skyscrapers regularly to detect any signs of subsidence or damage, regulating and reducing groundwater extraction in urban areas to avoid lowering the water table and causing soil compaction, implementing water conservation and recycling measures in skyscrapers to reduce water consumption and waste generation, promoting sustainable urban development practices that balance economic growth with environmental protection. Skyscrapers are symbols of human achievement and innovation that can enhance our quality of life in cities. But they also have a hidden impact on the ground beneath them that we need to be aware of and address. By understanding how skyscrapers affect the ground and cause subsidence, we can design and build them more responsibly and sustainably. New York City is one of the most densely populated and developed cities in the world, with more than 1 million buildings and skyscrapers that weigh nearly 1.7 trillion pounds. But this massive load of concrete and steel may be causing some parts of the city to sink into the ocean, according to a new study by scientists from the University of Rhode Island and the U.S. Geological Survey. The study found that New York City is sinking at a rate of 1 to 2 millimeters per year on average, due to the pressure that these structures exert on the Earth's crust. This process, known as subsidence, is faster in some areas than others, especially in Lower Manhattan, Brooklyn and Queens, where the ground is made of soft sediment and artificial fill. Subsidence is not a new phenomenon in New York City. The city has been gradually sinking for thousands of years, due to the natural rebound of the Earth's crust after being compressed by massive ice sheets during the last ice age. But the study suggests that human activities, such as building construction and groundwater extraction, may be accelerating this process and making it more uneven. Why does this matter? Because subsidence increases the risk of flooding and damages infrastructure in NYC. As sea levels rise due to climate change, coastal cities like New York face a growing threat of storm surges and high tides that can inundate low-lying areas and cause severe damage to buildings, roads, bridges and subway systems. According to a 2022 report by the National Oceanic and Atmospheric Administration, sea levels are projected to rise 10 to 12 inches on average along the U.S. coastline by 2050. Subsidence can worsen this threat by lowering the elevation of some parts of the city relative to sea level, making them more vulnerable to flooding. For example, Lower Manhattan, which is home to many financial and cultural landmarks, is currently only 1 to 2 meters above sea level. If it sinks further due to subsidence, it could face more frequent and severe flooding events, such as those caused by Hurricane Sandy in 2012. Subsidence can also damage infrastructure by exposing building foundations to salt water, which can corrode steel and weaken concrete. This can compromise the structural integrity and safety of buildings and bridges, and increase the cost of maintenance and repair. Subsidence can also affect underground utilities, such as water pipes and electrical cables, by causing them to crack or break. The study's authors warn that subsidence is a global problem that affects many coastal cities around the world. They suggest that mitigation strategies may need to be included in urban planning and development, such as reducing building loads, improving drainage systems, restoring natural wetlands and using renewable energy sources. They also call for more research and monitoring of subsidence rates and impacts in different locations. New York City may be sinking under the weight of its skyscrapers, but it doesn't have to drown in them. By taking action to reduce subsidence and adapt to sea level rise, the city can protect its people, its economy, and its culture from the rising waters.